find the sum of even divisors of 96 and perfect square divisors of 3600. And since we are given the prime factorization of 96 and 3600, we don't have to do that. So first of all, let us write down the sum of all the divisors or factors, both are same thing. Sum of all the divisors of 96, this will be equal to 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5 multiplied by 3 to the power 0 plus 3 to the power 1. So this will represent the sum of all the divisors of 96. But we are asked to find the even divisors of 96 only. So even divisor means that all the factors written down, all the factors of 96 should contain at least 1, 2. Now only the terms which will not have 2 will be because of this 2 to the power 0 present here. So if we'll remove this, and now multiply both the expressions, and if we'll multiply both the expressions now, then all the term will contain 1, 2 for sure, and thus the sum obtained now will be the sum of all the even divisors of 96. Now let us calculate this value. So this will be equal to 2 to the power 5 is 32, 2 to the power 4 is 16, 2 to the power 3 is 8, 8 plus 4 is 12, 12 plus 2 is 14. So this will give me 32 plus 30, which is 62. So this will be equal to 62 times 3 plus 1 is 4. So this is equal to 4 2s are 8 and 6 4s are 24, 248. So the sum of all the even divisors of 96 is equal to 248. Now let us talk about 3600. For 3600, first of all, let us write down sum of all the divisors of 3600. This will be equal to, so this will be equal to 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 cube plus 2 to the power 4 times 3 to the power 0 plus 3 to the power 1 plus 3 square times 5 to the power 0 plus 5 to the power 1 plus 5 square. But we wanted to know the perfect square, the divisors which are perfect squares. It means all those factors which will have prime numbers present in even quantities. The powers of the prime numbers, the powers of the factors which have prime numbers present in even numbers. For example, you can take anyone. Let's take 2 2s. Let us say for example, let's take 2 2s and multiply with 3 2s, this, and with 2 5 square. So now this term here contains all the prime numbers present in even quantities. Hence this will be a perfect square prime factor of 3600. So we want to know sum of all such prime factors, and the question is now how can we obtain that? So let us remove all those numbers which are present in odd quantities. For example, 2 to the power 1. I know that whenever I'll multiply this term with any of the terms here, I'll have just 1 2, and which is present in odd number. So I don't want this, so I'll remove this. 2 to the power 0 we can let it be because this is just a 1, so it won't make any difference. Again we'll remove 2 to the power 3 because this is present in odd number, so even that is gone. 3 to the power 1, again the same reason. 5 to the power 1, again this is gone. So finally what will be left is 2 to the power 0 plus 2 square plus 2 to the power 4 multiplied by 3 to the power 0 plus 3 square multiplied by 5 to the power 0 plus 5 square. So this will represent, the multiplication here will represent the sum of all the divisors of 3600 which are perfect square. Now let us calculate this. 2 to the power 4 is 16, 16 plus 4 is 20, 20 plus 1 is 21 times 3 square is 9, 9 plus 1 is 10 times 5 square is 25, 25 plus 1 is 26. So let us multiply this now. 26 times 21 is equal to 26, and 6 2s are 12, and 5. 50, 2, 6, 4 and 5. 546 multiplied with a 10 will give me 5460. Now we wanted the sum of this value and this value. So 5460 plus 248 will give me our final answer. So this is equal to 8, 10, 0, 4 to 6 and 7 and 5. 5708. So the question now says find the sum of even divisors of this and perfect square divisor of 3600, which is equal to 5708.